Hello, this is Dr. Stephen Bartlett, and today we're going to be going through lecture number 9, which has to deal with vertical curves. So let's go over the learning objectives and assignment. I want to remind you that all lectures 8 through 12 use workbooks, and since we're doing lecture 9 this week, we'll be working out of workbook 6. So the assignment you are to complete is in workbook 6. As you complete workbook 6, you're going to be asked to open up some drawing files, and so they'll be in Canvas in the files folder underneath another subfolder called drawings. Also, as you complete some of the exercises, there will be some additional data files, support files, and things that you're required to use. So you can find those again in the Canvas directory under drawings and then support files. Okay, let's just briefly go through the exercises. Exercise 1 is creating, displaying surface profiles with offsets. I'll show you what surface profiles mean in just a minute. Exercise 2 is creating surface profiles and offsets, so it's a continuation of exercise 1. Exercise 3 is changing the profile style within Civil 3D. Exercise 4 is reviewing surface profile characteristics. So this is mainly just a review. I'm not sure you have to do anything in that exercise. Yeah, that's true. You see, I've written here, no file submissions required for this exercise. So you're just supposed to go through it. Exercise 6 is creating a layout profile. Excuse me, that's exercise 5. Exercise 6 is editing a profile. Exercise 7 is copying a profile and offsetting it vertically. That means changing its elevation up and down. And then last is exercise 12, adding hatching patterns between the profiles. So in each of these cases where you are submitting the results, you'll be opening up the AutoCAD DWG files, and then when you've completed the exercise, I want you to give it this naming profile. Profile 1, exercise 1, last name, first name, .pdf. So remember again, Canvas does not accept DWG or drawing files, so we must print the drawing file out in a PDF format to submit for the TA for grading. Okay. So the next slide has to deal with profiles. So let's look at this. This is the results of a digital elevation model, a DEM. So we can see kind of we'll call it a 2.5D surface here, represented by maybe some mountainous terrain and then a canyon. So if we take that and cut a line through it and just expose kind of one plane in the vertical direction, so a plane in this direction, we would then see the terrain represented by this single line here, representing the mountains and then going down into the steep valley and then back up into mountains again. Okay, and so maybe to span this canyon we need to have a bridge. So the grade into the bridge is represented by this line. And what we mean by grade is the steepness of the slope into the bridge would be represented by this line. The tilt or alignment across the bridge will be represented here, and then the grade out of the bridge. So when we start looking at the alignments in a cross section in the vertical direction, then we're going to call those profile view. And you know, it's important in highway design to also get the steepness or grades of these slopes correct. Another nomenclature I want you to be familiar with is, let's say we have an existing topographical line here shown by the solid white line. Let the dashed line be the proposed maybe alignment in vertical section again. So we're looking again in profile view at this, and what the idea is as this vertical profile line crosses the valley, then if we were not to create a bridge, this would be a fill section, so we'd have to fill in this valley. with fill. And likewise, if we were to maintain this constant kind of grade out of that valley, then we'd be cutting the mountain here in the cut section. So one of the things that we do in highway design is we try to balance the cut and fill so that the amount of excavation that we would do in the cut section, we could transport it over and fill in this gully or draw or valley. So that's just to give you kind of the importance of not only getting these grade lines so that they're safe to travel for vehicles, but also there's some consideration about the terrain itself and how much cut and fill that we have to do. Obviously, trying to minimize the cut and fill would maybe give us a suboptimal section, so we do have to do some type of grading here and do some cut and fill. So let's get a little bit into the nomenclature about some of these fills. So we've created a curve. This is a profile line, a vertical profile grade line here that's going over a crest of a hill. So we'll call that a crest curve because it's cresting over the top of a hill. And similar to we used in horizontal alignment, we're going to call this point where we deviate from the tangent line. Think of this as a vertical tangent line. When we deviate from it, we'll call that the point of curvature. Quite often, if we're doing this in the notebook, we might put a V in front of that, so vertical point of curvature is where the curve begins off of the tangent line. Likewise, if we look at this other tangent line that's going backwards, where the two tangent lines intersect, that's the PI, or point of intersection. This is just like we learned with horizontal curves, but we might put a V there, VPI, to remind us that it's a vertical curve. And then where the curve meets the tangent line again is the point of tangency, or the vertical point of tangency. So the grade in positive is upward, so this is a positive grade upward, which is expressed in percent. So, for example, if we talk about a 5% curve, that means there's 5 feet of vertical rise for every 100 feet of horizontal distance. The grade coming out of this curve here is a minus because it's going downhill, and it would also be expressed in percent grade. And then the curve itself, as it deviates from the tangent line, of course, its radius is changing. Well, it's not its radius, but the curvature is changing, and so we have a change in the slope as we go between these two curves. Another thing that we may refer to as the distance between the PC and the PT is the length of curve, and in symmetrical curves, then the distance between there from the PC to the PI is L over 2, and likewise this distance over here would be L over 2. Similar to what we did with crest curves, we can use the same diagram, we just flip it over, and we can talk about sag curves, meaning now we're going down in a valley or downward, and we'd have the PC, PT, and then the PI. I've included in the notes a typical kind of plan sheet that you might see in a set of highway drawings, and just want to give you a little bit of background to how to interpret these. So this is plan view looking downward, and this would show the horizontal alignment. So we have the beginning of a curve here, the ending of a curve here, and then we have the curvature here, and then some of the information about that curve is given here. Since we're not doing surveying and layout, I'll kind of skip past these details. But we have right below it in cross-sectional view, or in plan view, in profile view, the vertical curve. So this represents, change in elevation. So we see there's a little bit of a cut section here, a fill section here, a slight cut section, another fill section, and cut. So this is the profile grade line, as it's called, that shows this. And then on this scale we'd have elevations here, so we could get the elevations there. Along this axis here we have stationing, so we can get the stationing. And so we would know the elevation of this curve at any point. So this, being able to interpret the horizontal curve and its information, the vertical curve and its information, is very important, not only for engineering, but for construction. Included in the notes is a simple example of how to create a profile grade line where we don't have a surface. So let me give you just an example where this might be useful. Let's say we've gone out on a survey and we've surveyed some points along the terrain, and maybe they're following something like this. So we don't have a surface, but at each one of these points we have the X, Y, and Z coordinates. Okay? Well, we can use Civil 3D, and it's explained in this video. I'm not going to go through the time to show you how to do it, but this is a very practical case where you may just have some survey data along a horizontal alignment, and you've shot these X, Y, and Z coordinates with survey with maybe a total station GPS unit or some type of transit system with a level. And so maybe these have a train, if we connect the dots, that show like this, and maybe we're wanting to design a highway that comes through here and might do something like that. So we can go ahead and do this and establish the existing terrain in Civil 3D. We can establish the vertical profile grade line, which is essentially what, as I've drawn it, a curve through this terrain. And then, we could have this AutoCAD Civil 3D tell us, the cut and fill along this, and we could do it quite quickly. Let's suppose maybe in this particular example we've got a lot of cut, and we wanted to explore dropping the grade line. I don't know if that's too visible. Let me find another color here. Let's try this color. Yeah, it kind of shows up. We want to drop the grade line something like this to minimize the amount of fill and cut. So this would be another case where we could do that, and that would allow us then to enter both those options within Civil 3D. In fact, there is one option where I think if you give it the amount of curvature, it will best fit to balance the cut and fill for you. So this is how we might use Civil 3D in a simple case where we don't have a true contour map with, a 2.5D surface. So as I spoke on the last slide, this video on this page here shows you how to create a best fit profile using Civil 3D where you're best fitting through some existing survey points. Again, we're not having a surface represented here, we're just fitting some vertical points on the profile line. So if you ever have to do this, in some type of simple design exercise, whether it be in senior design, or maybe if you're doing some preliminary evaluations for a roadway and a roadway alignment, this would be a useful thing to do and watch. So I want to give you just an example of how you can use, vertical and horizontal alignments to do preliminary engineering. When I was in Songdo at the Asian campus, this particular instance came up that we did some design for the citizens there to give them an idea of maybe some alternatives they had for alignment. So you're looking at the island of Songdo. This is, let me change here, this is all reclaimed ground here, meaning that this has been dredged. There's been a seawall created out here, and then the dredgings are placed behind the seawall. This is done in phases or stages, as you can see, and you can create new land. Anyway, in this particular case, the master plan had talked about a new future highway that would come out along the edge of the seawall and stay just off the coast, about 100 to 150 meters off the coast. In this location here, there is the existing freeway that comes from Songdo over to the Incheon International Airport. And the idea was to build this elevated highway, which would be on piling and piers in probably maybe 20 feet of water out here. So it's very expensive construction. But the issue came with the people that were going to be living in the apartments, particularly in the north end here that's just off the page. This is also going to be filled in with high-rise development. They would hear the traffic that would be coming from that elevated highway, and there was a lot of concern about noise and pollution. So we looked at this for them and came up with maybe a concept like this. Let me get to the next page. So this is just a schematic now, and what the idea was is to change the alignment from out here and bring it close to the seaport, but as we come in here inland and close to the land itself where the high rises would be, then we would put it in a enclosure. Later on, as this developed, they also wanted us to consider doing this zone here too, and this was just preliminary engineering to inform the citizens mainly of what the alternatives might be. So what was proposed, at least in the closed areas, let me give you an idea what that might look like. Here's the alignment that we drew out in AutoCAD. I won't go any trouble going through that, but we were just using the air photography and drawing the alignment along the coastline. But in the covered areas then that are enclosed, the idea then was to build, this would be precast concrete supported on piling, so this would be not cast in place. And this would be the existing seawall, and so the traffic would go inside the enclosure so that the noise and the fumes and that would be eliminated, and then the top of the enclosure would then be turned into a promenade so that the citizens could walk along the top along the seawall. On the side walls of this, because there's going to be fill here, since this is reclaimed ground, you couldn't put new earth and fill in this zone because you would cause settlement to the piling and that which would damage the structure. So we proposed them the concept of using lightweight fills to create this. So here's just some concepts here of what the side slopes of that could look like off of the enclosure. Now that doesn't look very good. Let's change back to photography here. Could be a Mediterranean style, or it could be sloped on the back wall with, this is to be the promenade ideas on this left hand side. On the right hand side, the back slope could be kind of terraces or amphitheater, or maybe some type of park with wooden benches and tables, or maybe just landscaped. But to create this, then we would be using lightweight materials like lightweight cellular concrete or expanded polystyrene, extremely lightweight fills to not cause settlement. So the importance of doing this in CAD and looking at this potential changes to the alignment for Songdo was that we were able to check the vertical grade lines in and out of the tunnels or enclosures to make sure they were no more than about 4% for truck traffic. And also we were able to check the design alignments along the design speeds along the alignment. I think we were shooting for about 65 kilometers per hour. It's about 40 miles per hour. So we were able to talk with essentially their Ministry of Transportation and say that at least in terms of alignment and that it would work. Of course, the idea of how much would this cost versus the elevated highway would have to be done by others. But it certainly, I was representing a citizen group, and it gave the citizen group much more credibility where we're able to do the layout in Civil 3D and say we think we could meet the design criteria given to us by the Ministry of Transportation. I might add also that the way I did this, I did it without a surface. So I was just using horizontal alignment laid out along the edge of the reclaimed ground using air photography and scaling that. And then the elevations across that area were quite flat, so there wasn't a lot of elevation change, but I was able to create a profile grade line to check both the curvature up to the bridges and then also the curvature down into the tunnel system. So I've recorded how I went through this process on this video. I present it to you maybe as something that you won't do exactly like this, but when you get into senior design, if we talk about trail systems with bridges and tunnels, or if we talk about roadway systems and that, knowing how to do some of these fundamental things will be beneficial to you in senior design. The remaining part of this lecture just has some visualizations. This first one is done by fairly sophisticated rendering that is not done in Civil 3D. Then there are some examples here also of some rendering done with Civil 3D. Clearly Civil 3D is not meant to be a sophisticated rendering showing all the architecture and three-dimensional features of a roadway system, but at least it can give you some rudimentary ideas of what the roadway system would do with. I'm not going to go into the details of animation, but sophisticated highway products, as you develop new alignments with new bridges, new cuts, new fills, new tunnels, can go through and develop that through taking the drawings in 3 dimensions and making them into a video for presentation to a client. So this ends my video for this week. We'll see you later.